Hello everyone, and welcome to Earth Archives. Do you know which is the smallest planet in the solar system? Many people would immediately say Pluto, but the answer is not Pluto, it's Mercury.
Since Pluto was reclassified as a dwarf planet by the International Astronomical Union in 2006, the list of the 8 major planets was officially revised. Among them, the smallest yet most intriguing member is Mercury. This planet, closest to the Sun, has a diameter of only about 4,880 kilometers, making it the mini representative of the 8-planet club. You might be surprised that Mercury is actually smaller than some of the larger moons. For example, Jupiter's moon Ganymede and Saturn's moon Titan both have diameters over 5,000 kilometers, making them larger in volume than Mercury. But don't underestimate Mercury. It is still a genuine planet because it orbits the Sun directly, rather than orbiting another planet. Although Mercury is small, it is full of unique charm. It experiences extreme temperature changes. Daytime temperatures can reach as high as 430 degrees Celsius, while at night it can drop suddenly to minus 180 degrees Celsius, creating a dramatic temperature contrast. Additionally, it has almost no atmosphere to protect its surface, so impact craters from meteorites are everywhere, making it look like an old soldier planet full of bullet holes. This also reflects Mercury's famously tough nature. Interestingly, Mercury's size often invites comparison with our Moon. Although the Moon's diameter is about 3,474 kilometers, making Mercury slightly larger, the two look very similar in appearance. Both are covered with impact craters and lack an atmosphere. In summary, although Mercury is the smallest of the 8 major planets, it holds a solid status, distinctive features, and plays an important role in the solar system. This small planet, scorched by sunlight and silently orbiting, proves that in the vast universe, small is never a limitation, but another kind of fascinating possibility.
Ha! It sounds so small and cute. But didn't you just say it's famous for being hard?
Don't be fooled by Mercury's petite size. It's actually one of the toughest little planets in the solar system. Its average density reaches as high as 5.4 g/cm superscript 3, a number almost on par with Earth's, ranking second in the solar system's density leaderboard, right behind our home planet. This isn't just because it's small, but due to its astonishing internal structure. Mercury's high density mainly comes from its massive iron core. This core makes up over 70% of the planet's entire diameter. Simply put, Mercury is like a metal ball floating in space, wrapped in a super thin rocky shell, with an almost entirely heavy metal core inside. Proportionally, its iron core is much larger compared to Earth's, which makes this tiny planet incredibly dense and compact. This extreme structure puzzles scientists. Why does Mercury have such a disproportionately large core? One theory suggests that early in its formation, Mercury experienced a massive impact that blasted away its original rocky shell, leaving only the heavy metal core behind. Another theory proposes that Mercury's original material distribution was simply different from the start, making it a natural metal lover. Whichever theory is correct, it highlights Mercury's uniqueness and mystery. It's not only the closest planet to the Sun, but also the most metallic and densely packed body in the solar system. Though it looks small and delicate, it's denser and more reserved than many larger bodies. Truly a tough and hardcore celestial object.
70%? Wow, that's like a huge iron ball wrapped in a thin rocky coat. No wonder it's called the Iron Planet.
Exactly. Mercury's reputation as a hardcore planet is no joke. This tiny planet very likely went through a cosmic disaster that changed its destiny. Scientists speculate that early in its formation, Mercury probably experienced a massive impact. A gigantic celestial body collided with it, stripping away its originally thick rocky shell and leaving behind only the heavy iron core and a very thin crust. Because of this, The Mercury we see today has such an unusual internal structure. Its iron core accounts for over 70% of its diameter, with a density of 5.4 g/cm superscript 3, almost the same as Earth, making it the second densest planet in the solar system. Despite its small size, Mercury is surprisingly heavy and incredibly solid, almost like a metallic steel ball flying through space. This giant impact hypothesis not only explains why Mercury lacks a thick atmosphere, but also why it contains more metal than other terrestrial planets like Venus, Earth, and Mars. From the outside, Mercury's surface is covered with impact craters, like a battle-hardened veteran of countless cosmic encounters. Its internal structure reveals an extreme form of evolution, losing its outer decorations and leaving only the purest essence behind.
It sounds like it had a rough time, like it got beaten up badly to end up like this.
You could say it's a kind of cosmic rebirth. Although Mercury likely lost most of its rocky shell due to a catastrophic giant impact in ancient times, this event also left it with an incredibly strong iron core, giving it a unique inner strength. And this power isn't just reflected in its density, it also shows up in an even cooler way, its magnetic field. You heard that right. Even though Mercury is the smallest of the 8 major planets, it still generates a planetary magnetic field, which is very rare for a small planet. Usually, only planets large enough like Earth, with a liquid metallic core that undergoes convection, can produce a magnetic field. But Mercury defies this rule, and, with its massive iron core, pulls off a physical miracle.
Wait, it has a magnetic field? I thought only big shots like Earth have one.
Although Mercury is small and its magnetic field is only about 1% as strong as Earth's, this weak but real magnetic field is hugely significant to scientists. It directly proves one thing: Mercury's core is still alive. You see, generating a planetary magnetic field requires a liquid metal core that keeps flowing to trigger what's called the dynamo effect. This internal convection creates electric currents, which then produce the planet's magnetic field. In other words, if a planet has a magnetic field, it means its interior still has active energy. Mercury surprised everyone by meeting this condition. People used to think that small, fast-cooling planets, like Mercury, would have long since solidified internally and become inactive. But Mercury proved that assumption wrong. Its oversized iron core, making up more than 70% of its diameter, still has at least part of it in a molten state, slowly flowing deep inside, allowing it to generate this faint but genuine magnetic field. Even cooler, NASA's Messenger spacecraft, during its close flybys of Mercury, measured the planet's magnetic field in detail. The results showed the field isn't evenly distributed, but slightly shifted toward the northern hemisphere, suggesting Mercury's core activity might differ from Earth's, and holds many mysteries yet to be solved.
Cool, so what does Mercury look like? Does it kind of resemble the moon?
Mercury's surface looks like a swollen moon. It's covered with countless meteor impact craters, with hardly any smooth areas. The planet's appearance records the turbulent history of the early solar system, with every crater marking a cosmic bullet from billions of years ago. Although Mercury and the Moon look similar, Mercury hides a surprising geological feature: huge cliffs. Some of these cliffs stretch for hundreds of kilometers and rise thousands of meters high, like wrinkles caused by the entire planet shrinking. They weren't formed by meteor impacts, but by Mercury itself shrinking. As its core cooled, the whole planet gradually contracted, causing the crust on the surface to compress and crack, creating these magnificent landforms. This process is like grapes drying into raisins. When the volume shrinks, wrinkles and cracks appear on the surface. This phenomenon of crustal contraction is rare on other planets and is one of Mercury's most striking features. It shows that even though Mercury is small and its geological activity seems subtle, it has undergone major internal changes. Moreover, observations from spacecraft suggest that these cliffs may still be slowly growing, indicating that Mercury's geological evolution hasn't completely stopped yet.
The shrinking planet. That sounds so sad. How much has it actually shrunk?
Mercury is indeed an old planet, and its appearance is the most direct proof of that. According to scientists' observations and models, Mercury's diameter has shrunk by at least 7 kilometers over the past billions of years. You heard that right, not just surface depressions, but the entire planet has been slowly shrinking, like a fruit gradually drying out. This change comes from the loss of internal heat. When Mercury first formed in the early solar system, its interior temperature was extremely high, and its metal core was molten. But over time, Mercury started to cool down. The iron core gradually solidified and contracted, causing the whole planet to shrink as well. Just like human skin loses elasticity and wrinkles with age, Mercury's crust developed spectacular cliffs and wrinkles. These crustal cliffs are called lobate scarps, some stretching hundreds of kilometers long and thousands of meters high, like huge wrinkles crumpled across the planet's surface. They're not only impressive, but also one of Mercury's most distinctive geological features. Even more astonishing, some of these scarps appear relatively young, suggesting that Mercury's crust may still be slowly deforming today.
So Mercury can age too. What about its environment? Is it really terrifying?
If you think deserts are hot, you probably haven't experienced Mercury's hellish environment. This planet, the closest to the Sun at just about 58 million kilometers away, is basically running right next to the Sun. On top of that, its atmosphere is almost non-existent, so thin it can't block the Sun's scorching radiation or retain any heat, making Mercury the solar system's most extreme temperature factory. During the day, Mercury's surface is fully exposed to direct sunlight, with temperatures soaring up to 430 degrees Celsius, hot enough to melt lead and vaporize zinc. But at night, things flip instantly. Without a stable atmosphere like Earth's to keep the heat in, Mercury loses its heat rapidly, and temperatures can plummet to minus 180 degrees Celsius. This extreme temperature difference of over 600 degrees Celsius makes Mercury a true battlefield of hot and cold. Such conditions make it nearly impossible for any form of life to survive, and even machines struggle to endure. NASA's Messenger spacecraft had to be equipped with special heat-resistant materials and thermal control systems just to operate in this environment for years without failing. Even more fascinating, despite being so hot, Mercury may harbor water ice at its poles. Because Mercury's rotation axis is almost vertical, some craters at the poles remain permanently shadowed from sunlight, with temperatures low enough to preserve ice over long periods. This has become a major focus of study for astronomers.
Oh my gosh, being roasted like a barbecue in the morning and then turning into a popsicle at night, it's basically a cosmic double punishment.
You said it perfectly. Mercury is definitely one of the planets in the solar system with the most extreme temperature swings, like an extreme weather simulator of the cosmos. It's a furnace by day and a freezer by night. This drastic change all comes down to its unique position and structure. First of all, Mercury's location dooms it to a tough life. It's only about 58 million kilometers from the Sun on average, making it the closest of the 8 major planets. The Sun appears 2 to 3 times bigger and brighter in Mercury's sky than it does from Earth. That alone is like a non-stop solar bombardment. But the problem isn't just its proximity to the Sun. What makes it worse is that Mercury has almost no atmosphere. Unlike Earth, which has an atmosphere that reflects sunlight and stores heat, Mercury's atmosphere is extremely thin, practically non-existent. This means solar radiation hits the surface directly and without mercy, pushing temperatures up to 430 degrees Celsius during the day, hot enough to melt lead and zinc. Then, at night, without any insulation, temperatures plummet to minus 180 degrees Celsius, turning it into an icebox instantly. The day-to-night temperature difference exceeds 600 degrees Celsius. This super extreme environment rightfully earns Mercury the title of king of temperature swings in the solar system. It's even more dramatic than Venus. In fact, although Venus is hotter overall, its thick atmosphere keeps temperatures very stable. Mercury, on the other hand, switches instantly from blazing hell to freezing cold. This makes designing spacecraft to explore it a huge challenge. How do you survive being roasted during the day and frozen solid at night? This temperature hell training is a real test for space technology.
But its name, Mercury, sounds pretty romantic, doesn't it?
The name Mercury is actually quite fitting. It comes from the Roman god Mercury, a swift messenger deity who wore winged sandals and moved as fast as the wind. And Mercury's performance in the solar system matches this flying god perfectly. It's the fastest planet in orbit. Because Mercury's orbit is so close to the Sun, it's pulled strongly by its gravity, making its orbital speed extremely fast, about 47.87 kilometers per second, faster than any other planet. Because of this, it completes one orbit around the Sun in just 88 Earth days. In other words, a year on Mercury is less than 3 months long. You could race from spring to winter and start again in no time. This incredibly fast age clock is why astronomers call Mercury the messenger of the Sun. In the night sky, it always appears near the Sun, visible only briefly before dawn or after dusk, like a swift courier who never lingers. Because of this, ancient people quickly noticed this agile little planet and named it after the mythological messenger Mercury, adding a layer of culture and mystery to it. But this rapid orbit also brings some strange phenomena. For example, Mercury takes about 59 Earth days to rotate once on its axis, but 88 days to orbit the Sun. This causes the so-called solar day on Mercury, from one sunrise to the next, to last nearly 176 Earth days. That means you'd have to wait for 2 Mercury years just to see the Sun rise once.
Wow! So Mercury is the sprint champion of the universe?
Mercury's rotation and orbit hide an amazing cosmic rhythm known as the famous 3:2 resonance. Specifically, Mercury takes about 59 Earth days to complete one rotation and 88 Earth days to orbit the Sun once. These two cycles align in a special ratio. Mercury rotates exactly twice for every 3 orbits around the Sun, creating a unique 3:2 spin-orbit resonance. This distinctive motion leads to a very rare and fascinating astronomical phenomenon. It takes Mercury 176 Earth days from one sunrise to the next. In other words, one day on Mercury lasts as long as 2 Earth years. Imagine the slow pace of day and night cycles, making each day and night on Mercury long and drawn out. How did this resonance form? It's mainly due to the Sun's powerful gravitational tidal forces acting on Mercury, gradually adjusting its rotation speed until it's settled into this stable orbital rhythm. Unlike the Moon's tidal locking with Earth, Mercury isn't locked facing the Sun with one side forever. Instead, it exists in this semi-lock state, maintaining a unique and intriguing pattern of rotation and orbit.
Seriously? That time logic is totally mind-blowing. So you have to live through 2 years on Mercury just to see one sunrise?
Imagine you're an astronaut setting foot on Mercury, a planet full of extremes and wonders, waiting for the Sun to slowly rise above the horizon, and it takes 176 Earth days to happen. That's almost half a year on Earth. Such a long wait might even turn your hair gray. Mercury's unique 3:2 spin-orbit resonance creates this incredible phenomenon. Although it only takes 88 days to orbit the Sun once, its slow rotation means that from one sunrise to the next actually takes 176 days. This means one day on Mercury equals 2 years on Earth. The daytime stretches endlessly like a blazing, eternal furnace, and the night turns into a freezing icebox, with extreme temperature swings challenging any life form or machine. If you were standing on Mercury's surface, imagine the sun slowly climbing, its rays gradually piercing through the thin atmosphere, the heat seeping through your spacesuit, making you feel like you've lived through several summers and winters. Then, as the sun sets, temperatures plummet rapidly to minus 180 degrees Celsius, forcing you to brace yourself for a bone-chilling night. This extreme day-night temperature difference and long cycle make Mercury one of the most challenging environments in the solar system.
Haha. With such an extreme environment, are there any surprising things on Mercury's surface?
You know what? Although Mercury's overall environment is extremely hot, there's an amazing secret hidden at its poles, permanently shadowed regions that actually contain water ice. It sounds unbelievable since Mercury is the closest planet to the Sun, with daytime temperatures soaring up to 430 degrees Celsius. How could there possibly be ice? This all comes down to Mercury's nearly vertical axis of rotation, which means certain areas at its poles never receive direct sunlight. These perpetually shadowed regions are called permanent shadowed regions or eternal night zones. Because no sunlight ever reaches them, temperatures there stay incredibly low, allowing water ice to remain stable for long periods. In fact, these spots are some of the few places in the inner solar system where ice can survive so close to the Sun. This incredible discovery was thanks to NASA's Messenger spacecraft, which orbited Mercury from 2011 to 2015. Using radar and spectrometers, it identified highly reflective areas in the polar shadows, typical signatures of water ice. Most of this ice is hidden in the bottoms of impact craters, acting like natural refrigerators, preserving these precious water resources.
Wow, ice and fire at the same time. Scorching hot during the day, but frozen at the poles.
Mercury, the smallest planet in the solar system and the closest to the Sun, possesses an astonishing and paradoxical charm. Its surface experiences extreme heat and cold simultaneously. It harbors water ice at its poles. And most importantly, its seemingly quiet landscape is a treasure trove for exploring the early history of the universe. All of this stems from Mercury's unique geological and astronomical characteristics. One of the biggest differences between Mercury and Earth is that Mercury has no plate tectonics. Earth's surface plates are constantly moving and colliding, creating mountains, trenches, and volcanoes. But Mercury is completely different. Its crust is almost motionless, lacking Earth-like geological activity. Its surface has remained stable for billions of years, untouched and unaltered by tectonic shifts. This makes Mercury a true time capsule, quietly preserving the original marks from the solar system's formation billions of years ago. Mercury's surface is densely covered with impact craters and massive cliffs, but these features are not recent. They are the scars left behind from early cosmic impacts and cooling processes billions of years ago. These marks are like pages in the universe's history book, recording the chaos and evolution of the solar system's infancy. By studying Mercury, scientists can glimpse the environment of the solar system's earliest days and unlock the secrets of planetary birth and evolution.
So even though Mercury is small, it's like an antique museum in the universe?
Mercury, the mysterious planet closest to the Sun, carries the weight of over 4 billion years of changes in the solar system. For scientists, it's not just a small planet in the solar system, but a precious time capsule that records the oldest history and secrets of the universe. Since the very birth of the solar system, Mercury has quietly preserved its landscape marked by billions of years of history. Impact craters, massive cliffs, and icy poles. All these serve as important clues for scientists to decode the early environment of the solar system. Because Mercury has no plate tectonics, and its crust remains almost motionless, its surface preserves the most pristine cosmic records, like a three-dimensional history book showcasing the evolution of the solar system. Mercury's surface has endured countless meteorite impacts, which not only shaped its crater terrain, but also provided scientists with valuable data to study early planetary collisions and material composition. Coupled with the presence of polar ice, Mercury has become an ideal example for researching the distribution and preservation of water resources in the cosmos.
Wow, after hearing all that, I really think Mercury is a pint-sized tough guy, low-key on the outside but hardcore to the core.
Mercury, this small planet on the edge of the solar system, is like a silent observer in the cosmos. It doesn't boast or shine brightly, yet it has quietly witnessed the solar system's over 4 billion years of dramatic changes, becoming an irreplaceable historical witness in the eyes of scientists. Compared to those dazzling planets, Mercury's presence seems much more understated. But it's precisely this quietness that makes it the best window to understand the universe's past. Mercury's surface is covered with countless impact craters and cliffs. These landscapes are like the marks of time, silently recording the universe's repeated violent collisions and transformations. Because Mercury lacks geological activity, these traces have been preserved for so long, resembling a silent history museum telling humanity the story of the solar system's birth and evolution. Mercury's silence is not emptiness. Through its very existence, it tells the story of the cosmos. Scientists, by studying Mercury, can decode the early solar system's environment and changes, understand how planets formed, and even explore the distribution of water resources in the universe. NASA's Messenger mission brought back a wealth of precious data, confirming the presence of water ice at Mercury's poles and revealing the planet's unique geological features, allowing humanity to glimpse more secrets of the cosmos.
Alright, that's all for today. If you think Mercury is as cool as we do, don't forget to like, subscribe, and hit the notification bell. Leave us a comment telling us which secret about Mercury surprised you the most.
And don't forget to follow us for updates. Next time, we'll take you to meet other stars of the solar system.